All right, here we are in lesson 2-1, module 2, lesson 1, greatest common factor. Again, you should have already watched the vocabulary video that talks about what a greatest common factor is. Today we're going to talk about how to find the greatest common factor of two whole numbers that are less than or equal to 100. So any number that's between 1 and 100, that's a whole number, we're going to find the greatest common factor of those numbers. And then we're also going to use the distributive property to express the sum of two whole numbers between 1 and 100, with a common factor as a multiple of a sum of two whole numbers with no common factor. That is a mouthful. Basically what's going to happen is we are going to take two whole numbers, all right, and we are going to express them as a multiplication problem using a common factor. Okay, when we get there, we'll show you what we're talking about. Don't stress about it. I know it sounds super confusing. All right, rest assured it sounds super confusing to me too, so I can completely understand why you would feel confused as well. So here we go. So understanding greatest common factor. So a florist makes bouquets from 18 roses and 30 tulips. All the bouquets will include both roses and tulips. If all the bouquets are identical, what are the possible bouquets that can be made? So first things first is let's highlight the question. So what are the possible bouquets that can be made? And important information, we'll make that black, sorry about that. If all the bouquets are identical, okay? So that means that if one bouquet has 4 tulips and 3 roses, that the other one has to have 4 tulips and 3 roses. But we only have 18 roses to work with and 30 tulips, all right? So what we're going to do is we're going to sit down and we're going to say, okay, how many bouquets can we make with roses? And make sure that because we want to use all of them. So I could make one bouquet of roses and have them all be in there, so all 18. I could make 2 bouquets and 9 would go into each. If I made 3 bouquets, then 6 roses would go into each. If I made 6 bouquets, then 3 would go into each. If I made 9 bouquets, then 2 roses would go in each. And if I made 18 bouquets, then 1 rose would go into each. Okay, so these are the different ways that we can split up the roses. So now let's look at the different ways, and again, you'll see these are all your multiplication facts and factors. So all these numbers are factors of 18. All right, so we took 18, divided it by 1, put 18 in a group. Took 18, divided it into 2 groups, put 9 in each group, so on and so forth. Now we're going to do that with the tulips. Well, if I make 1 bouquet, I have to put all 30 tulips in it. If I make 2 bouquets, I can divide that evenly and put 15 in each. If I make 3 bouquets, I can put 10 in each. If I make 5 bouquets, then I can put 6 in each. And then if I make 6 bouquets, I can put 5 tulips in each. Excuse me. If I make 10 bouquets, I have to put 3 tulips in each. 15, I would put 2. And 30, I would put 1. So now let's take a look, and we have to see, well, I want to use both. It's not one or the other. I want to use both. So I want to look at my factors for both of the numbers. Can the florist make 5 bouquets using all the flowers? Okay, and explain why or why not. Well, if you look here at the tulips, they can make 5 bouquets and use all the flowers. However, up here by the roses, they're not able to take 5. They're not able to make 5 bouquets and use all of the tulips. If I made 5 bouquets, maybe I could put 3 in each, but then I would have some left over. Okay, so in this case, my answer would be, get my tool out here, no, 18, the number of roses, cannot be divided by 5 evenly. I don't want to say evenly, cannot be divided by 5 without a remainder. Meaning there would be flowers left over. Okay, so basically what you're looking at is saying, okay, well, do they have common factors? And in this case, 5 is not a common factor. So what are those common factors of 18 and 30? Well, let's take a look. I have 1. Oops. There we go. I have 1. 1 is a common factor. 2 is a common factor. 3, not 5, 6, not 9, not 10, not 15, not 18, not 30. So my common factors are 1, 2, 3, and 6. All right. Now here, what I want to look at is what is the largest of those common factors. So the greatest meaning the biggest, common meaning the same. So the greatest common factor for these is going to be 6 because 6 is the largest factor that they both have that is the same. So what this means is they can make 6 bouquets and use all of the flowers. That is the largest amount of bouquets that they can make and use all the flowers. They could also make 3 bouquets and they would use all the flowers, but they would make less bouquets. So if they want to make the most that they can make, they want to use 6. So looking here, suppose the florist has 18 roses and 36 tulips. What is the GCF of the number of those tulips? Right? So looking at this, this is where I'm actually going to jump to a different method here. And we're actually going to use a method called the ladder method. All right, so here we have that there's 18 tulips and 36 roses, is that correct? Or 18 roses and 36 tulips. I had that backwards, I apologize. All right, and we're just going to take out the third factor for now, so just kind of ignore these extra lines here. So what we do is we look at the two numbers and we find a prime factor that they both have in common. So it has to be prime. It has to be a number that can only be divided by 1 in itself. In this case, both of these numbers can be divided by 3. 18 divided by 3 is 6, and 36 divided by 3 is 12. We look at it again, 6 and 12, they can both be divided by 3. And then I get 6 divided by 3 is 2, and 12 divided by 3 is 4. And then now I want to take a look again. The prime number that can divide both of these is 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now the only prime number left that can divide both of these is 1. So what I do is I take these 3 numbers and I multiply them. 3 times 3 times 2 times 1. Now, 1 times anything is itself. So honestly, we can leave this 1 out of it and just say that 3 times 3 is 9 times 2, because we bring the 2 down, is 18. So now I have found the greatest common factor of 18 and 36 is 18. Okay, so again, this is another method that you can use to find the GCF. So go back here. What is the GCF of the number of roses and the number of tulips? Again, the GCF is 18. And we could have known that more quickly. I wanted to show you the next method. But if you list the multiples of 18, the next multiple is 36. So since 36 is a multiple of 18, and 18 is the largest factor that 18 can have, I know that 18 has to be the GCF. So the GCF of 18 and 36 is 18 because 36 is a multiple of 18. So whenever one number is a multiple of the other, your GCF is going to be that smaller number. So for example, 4 and 2. Well, 2 is a multiple of 4, so 4 is a multiple of 2, so the GCF in this case has to be 2. How about 10 and 20? Well, 20 is a multiple of 10, so the GCF has to be 10. So if you know your multiples really well, it's really easy to find the greatest common factor for problems like these. Okay, going to the next problem, I'm just going to kind of read over it with you. So we have a baker that has 24 sesame bagels and 36 plain bagels to put into boxes. Each box must have the same number of each type of bagel. That's important. 24 and 36. What's the greatest number of boxes that the baker can make using all of the bagels? And then how many, so here's 2 questions here. There's 2 questions, so there's 2 parts. So what is the greatest number of boxes that the baker can make using all of the bagels? And then since there's a second question, I'm going to grab a second color. How many sesame bagels and how many plain bagels will be in each box? Right? So again, you have to take it and figure out, if I have to use all of them, I have to use a factor of each number. So the factors of 24, because there's 24 bagels, are 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now this part's probably what is going to take you the longest, is to write down all your factors. But now I find the ones that they have in common. So they have 1 in common, 2, 3, 4, 6, and 12. And again, I want the greatest number of boxes. So I want the most boxes that I can use. So he'll be able to make 12 boxes. That's the biggest number of boxes. Okay? And then now to figure out how many are in each box, I'm going to divide each of those numbers by 12. So if I take 24 and divide it by 12, I know that there's going to be 2 sesame bagels in each. And then if I take 36 and divide it by 12, I know that there are going to be 3 plain bagels in each. Right. So again, you're taking your numbers, and if you're trying to figure out the largest number of boxes or groups that you can make, you find that greatest common factor. And then you use that greatest common factor to divide it and figure out how many would go in each group. It will come with time and more practice, I promise. So what is the GCF of 2 prime numbers? Well, you have to remember, prime numbers are divisible by 1 and themselves. So the only number that those numbers are going to have in common is 1. So the GCF of any 2 prime numbers will always be 1 because that's the only one that they have in common. Ooh, I'm running out of space here. All right. Okay, and then given an example, so like 2 and 3. 2 and 3, if I list the factors of 2 are 1 and 2, and the factors of 3 are 1 and 3. So the GCF there would be 1. All right, so there's our ladder method example. Okay, so now we're going to find the GCF of each pair. I want you to try this on your own. I want you to use the listing method. Actually, no, let's do it together. The list method, and then we'll use the ladder method here. So for the listing method, I'm going to list the the factors of 14. So 1 and 14. 2, because 14 is divisible by 2. 14 divided by 2 is 7. 14 is not divisible by 3. It's not divisible by 4. It's not divisible by 5. It's not divisible by 6. But it's divisible by 7, which we've already used, so we found all the factors. 35 is divisible by 1 and 35. It is not divisible by 2 because it's odd. It's not divisible by 3 because 5 plus 3 is 8, which is not divisible by 3. It is not divisible by 4. It is divisible by 5, and if you divide it by 5, you get 7. And then I know it's also not divisible by 6. So here I see that 7 is the largest factor that they have in common. Now using the ladder method, I have 20 and 28. A prime number that divides them both would be 2. 20 divided by 2 is 10. 28 divided by 2 is 14. Excuse me, so then now I have 14 and 10 divided by, and then the prime number that can divide both of them is 2. 10 divided by 2 is 5. 14 divided by 2 is 7. The largest prime number that can divide both of those is 1. So I stop there and I multiply my other two prime numbers and I get 4. So the GCF of 20 and 28 is 4. Okay, the 6th grade class is competing in the school field day. There are 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. Same number of girls, same number of boys. So that doesn't mean that each team has to have 5 girls and 5 boys. That means if team 1 has 5 girls, then team 2 has to have 5 girls. Okay, so it's not the number of boys and girls in the group that's the same, it's the number of girls in every group that's the same. Okay, so then the question here, what is the greatest number of teams that can be formed? And then how many boys and how many girls will be on each team? So the key there, that key word should be the greatest number. That should tell you that you want to take and find the greatest common factor. Because if you find the greatest common factor, that tells you the biggest number that you can divide all the teams by. So that's the biggest number of groups that you can have. So I'm going to use the ladder method and do 32 and 40 and find the largest number of groups that we can have. So I divide them both by, well, I'm just going to go with 2. I get 16 and 20 and divide them both by 2 because they can both be divided by 2, and I get 8 and 10. Can divide both of those by 2, and I get 4 and 5. And those can only be divided by, both be divided by 1. So I multiply these 3, and I get 6. Okay, so the greatest number of teams that I can make is 6. So that tells me to find the number of boys. I will take the 40 boys. I'm sorry, 2 times 2 times 2 is 8. Oh, this is why you don't do this when you're not feeling well. My bad. 2 times 2, I did 2 plus 2 plus 2. So I take the number of boys, I divide it by 8, and I get 5. Now notice, I would have used 6, and when I did the division problem, I realized that that doesn't work. 40 divided by 6 will give me a remainder. So I went back and I fixed and double-checked my answer. That's okay. We all make mistakes. It's fixing them that's the important part. So I know that I can put 5 boys on each team. So 8 teams with 5 boys. And, because I'm running out of room here, I'll take the number of girls, which is 32, divided by 8, and that gives me 4. So 8 boys and 4 girls. All right, so using the distributive property. You can use the distributive property to rewrite a sum of 2 or more numbers as a product of their GCF and a sum of numbers with no common factor. Okay, so this is really confusing to read this first part, so let's just dive into it and take a look at how it works. All right, so here, what do the side lengths of the area models, 1, 3, 5, 9, 15, and 45, what do they represent? So these numbers here, these are all what? Okay, all of these are factors, so 1, 45, 3, 15, 5, and 9. These are all factors of 45. Okay, so on your own grid paper, show all the possible area models of 60. What you're gonna find here is that you'll get 1 by 60. And actually, you know what? I changed my mind. I went back and forth on this. I want to do this together as a class. So this we're gonna do in class. I'm allowed to do that. I can change my mind and make your video shorter. I think you'll all enjoy that. Okay, so then this reflection part, we're also going to do that together in class because I think that it's just going to help make more sense if we can do it together and you can see a nice, bigger and better drawing on the board, okay? So you don't have to do these reflect problems. We're going to do these, trying to write the words in class on here. All right, and then here, you just have to do 1 and 4. So 1 and 4. Okay, take your time, use your ride, read the problem, identify important information, determine a plan or draw a picture. Drawing a picture could really help for these, and then evaluate or execute. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.